What about now? Great, fantastic. So very happy to be here and present our work in progress. My name is Jiejun, and I'm here with my co-author, James Stolford, sitting here. So today I'm going to discuss a very interesting topic called human-machine social system, but with a very, very boring title. I use a game theory model to try to analyze this futuristic idea. So what is human-machine social system? So we're considering in a more futuristic view about how human and machine will interact with each other, considering that they are interacting in the same social environment. They are able to build social relationship such as trust, empathy, cooperation, coordination, anything that you can think about, human and human can build the relationship together. And of course, we also want to think about the structure will emerge during this social interaction. So here I have a nice assumption that our machine in the future will be autonomous and artificial intelligence empowered or machine learning empowered agents that will participate in very similar tasks as humans and operating in a similar social sphere. So in order to make this whole system work, of course, we need to have some communication going on between the humans and the machines. So we consider it in 3 levels. Of course, we have the traditional level, human-human communication using social networks. Of course, also in a very traditional way that I approach to you and talk to you. We share ideas. We sometimes also can use computers, other technology as medium in order to assist the communication between us. And of course, we want to consider about another level of human-computer or human-machine communication that will happen during people directly sharing information or seek for some suggestions from machines. And of course, machine can share information with human beings and try to influence their behavior or just to increase some knowledge base for human beings. And of course, we want to consider another layer in the social system is the machine-machine communication. They can communicate intentionally, such as in the distributed systems. Sometimes, well, regularly, machines should send heartbeat to the coordinator and to say that, I'm still online, send me tasks. Or nowadays, it can happen also unintentionally by doing cross-programming. Say, consider that one machine is going to generate some artificial data and then feed this artificial data into other machines. So that actually considered as another level of communication. So these things will happen. And what makes human-machine social system so different? It is very different from HCI because HCI basically proposed an idea about how can we assist human using machine more smoothly to assist the communication, and only on that level. For artificial intelligence or machine learning algorithms, they also make autonomous machine possible, but they only focus on the cognition or decision-making process individually. And now the system become bigger and bigger and bigger. They're actually influencing each other. They're forming groups and they're trying to, become more powerful by observing more information, both sides. So I would say human-machine social system provide new research topics, interest, or potentials. And it's necessary for us to consider about this large-scale dynamic or social behavior, or consider about what kind of emergent behavior will appear. Right, so this is my evil machine coming up, and people are not happy. Because I'm proposing an idea that is sort of like more futuristic. It's not happening now, but I think it will happen in the future. Hopefully that will happen in the future in a good way. In order to consider about the future, I think we should look back about how people interact with algorithm in large scale. So just consider about the extreme and very popular system called algorithmic trading system. Usually it's designed in a way that it wants to promote frequency trading, it wants to minimize the cost, it wants to exploit market opportunities, develop different marketing tactics, things like that. So financial institute began to more and more accept this idea about using algorithm to trade instead of using human traders. It's much more efficient, maybe cost less. And then this idea become more and more accepted, increasing adoption that shows a degree of human beings are very happy with the algorithm, what they're doing. And then that will increase the development of some certain algorithm. Algorithm began to become more clever in a way that data analytics can be involved, machine learning can be involved. And eventually, the algorithms are not only reacting to the current stage in the market, but also reacting about other decisions made by other algorithms. And that thing can happen, for example, flash crash. So it's just when you did not position your objective in a good way, then some kind of disaster will happen. The same thing goes with echo chamber. That's also when we show a lot of affection to social media and then we drag ourselves into some certain deep hole. So there is risk and we want to avoid that. That's our motivation of using mathematical model to analyze this whole thing. Right. So for this work in progress, our aim is quite simple. First of all, to provide an abstraction of how humans and machines interact at scale without overcomplicating the model with the detail of a single machine. So in this model, we're not considering about the machine software, hardware implementation. We're not thinking about the storage capacity of a machine. So we only take it as an autonomous agent that can do some kind of interaction with human and machine. And also because we want to analyze this satisfaction, human and machine interaction, and they're using information to trigger this whole process, then we need to abstract this information into a certain degree. So here we only use satisfaction as an indicator from the human to the machines to study the impact of how satisfaction can influence large-scale machine behavior. Right. So I will keep the math in a very minimum, because if we want to do it in a, if I want to discuss it in a very sophisticated way, then I'll probably take another hour, but here we are. So we focus on the machine behaviors, considering that the square is a machine, and the machine will have a state, is time dependent. Here I define the machine state is intelligent maturity, how clever they are. And of course, if machine wants to cooperate with people, there will be a cooperation cost happening, regardless of how they want to process the data or whatever. And also, we do have a piece of information from the human, and human are the circles in this figure. So humans will give some satisfaction information to the machine in order to direct the machine in a better way. Machine will talk to each other, sharing informations, and that happens in a large scale. And that is the main reason of using mean field game theory instead of using traditional game theory, because traditional game theory talking about very limited number of agents. And here we will have a really large scale of clever machines interacting with each other. And using traditional game theory makes this problem not traceable. So our mean field term is included in this model as well, mainly used for machine and machine communication. So we only capture, say, this machine here, neighbors, average intellectual maturity. So that will happen, and all this interaction will help our current agent machine moving to another state. And considering about the current state, consider about our mean field term, which is the peer state. Here is a theta, and the cooperation cost, the satisfaction. We want to make this model a bit more realistic by adding some randomness into the model. And that's basically how we model the machine's behavior. And here we will have a lovely minimization problem. Here, if you're not really into mathematics, then I also have this version. So basically, machine is trying to minimize the cost. And the cost is associated with cooperation cost, communication cost with the peers, and also some satisfaction from the human beings that machines will take this piece of information as a positive feedback. So here you can also consider the satisfaction as a reward for the whole cost function. And for the nice PDE down there is basically what I discussed in the previous slides. So this whole minimization problem can use a few tricks, and then I will use HJB and FPK. FPK is Fokker-Planck-Markov equation. So basically that equation is borrowed from physics and to analyze particle movement. If we can imagine our machine's behavior as a particle, well, machine as a particle, and the machine will be influenced by their neighbor machines using some force, say drag force or random force. And in our case, the force would be the peers' intelligent maturity, because they need to communicate with each other, which will lead the machine into another state or into another dynamic. So that's why I use this combination. Well, HJB basically provide us a nice solution of the optimal control. And if you want to have more detail about how the math look like, I have recently a paper published, and just refer to that paper. You will see the technical report. You will see how I adjust the weights of the model and everything. So I'm not going to introduce too much about that here. Some results, very preliminary. The first one is we want to have a look how the mean intelligence maturity will evolve during time by considering different satisfactions from human being. So which is not really surprising, because the more satisfaction, the more intensive you can consider, the more intensive human beings will interact with the machines, right? So it will sort of help the machine become more and more clever. And the other part on the right-hand side, it's something began a bit tricky. So we could observe that when the satisfaction level is quite low, the cooperation, the collective cooperation from the machines, they're positive, means that they're cooperating with human being. But when the satisfaction become higher and higher and higher, we see that the cooperation goes negative, which means that they're not cooperating. They don't like to cooperate at all. We would like to use this result to analyze, to explain some some phenomena, societal phenomena. And could be one of the solutions, say that AI system can be lazy in the more intensive interaction with human beings. So for our future work, 3 main points. Our model before I proposed is very, very simple. I only modeled the machine's behavior. And in the future, we want to involve the decision-making process of human beings when interacting with machines. And also to study the emergent behavior of human machine together in this social system, and investigate under what kind of condition we can actually promote collective, cooperative machine-human interaction. And lastly, we want to explore how to direct cooperative AI in a messy world. It means that we will have different kind of agents empowered by different kind of machine learning algorithms. And we will also have different human groups together with different values, and how can we analyze this whole scenario at a scale. So that's what I might talk about today. And feel free to grab us if you want to have a deeper conversation. Thanks.